Hello everyone, I am Prabha, working as an assistant professor in Department of Chemistry at Karpam Academy of Higher Education. In last video we see about periodic law and present form of periodic table, and today we see about the topic electronic configuration of elements and periodic table. In periodic table, the electronic configuration of elements classified into two types. One is electronic configuration along with period, and another type electronic configuration along with group. These two types is we see about in this topic. Okay. So first we see about electronic configuration along with period. Okay. So in electronic configuration along with period, it is in periodic table we already see about the period is totally 7. That means n equal to 1 to n equal to 7. This number of n's are classified the quantum numbers. So the electrons position and their energies of atom is classified into set of quantum numbers, that is 4 types of quantum number. The first one is principal quantum number, and another one is azimuthal or angular quantum number, and third one is magnetic quantum number, and fourth one is spin quantum number. Okay. So this 4 set of quantum numbers explains the position and energy of electron arranged in the atoms. Okay. Here the n numbers are explains the or follow the principal quantum number. In principal quantum number, it defines the electron filling in main shells, that means K, L, M, and this K, L, M, N are referred as a shell, SHELL, shell. Okay. Next another second quantum number, that means azimuthal or angular quantum number, explains the electron position in the orbitals. So these orbitals are known as SPDF. This SPDF is referred as an orbitals, or otherwise it is referred as an subcells. Okay. The electron filled in this subcells or orbitals is known as electronic configuration. So the filling of electrons in the subcells is referred as electronic configuration. So here the electronic configuration of elements mainly depends of this principal quantum number and azimuthal quantum number. Okay. So electronic configuration along period. Okay. It is up to n equal to 1 to n equal to 7. Okay. In n equal to 1 means it represents, we already seen about this, n represents the principal quantum number, and this principal quantum number defines the filling of electron in main shells. Okay. So this n1 defines the shell K, and the n2 defines the cell L, and n3 defines the cell M. Likewise n4 defines the cell N. So up to N, the cells are K, L, M, N, O, P, Q up to Q. Okay, these are main cells. Okay, shell, electronic shells. And another second quantum number, azimuthal. That is defines the electron filling in the subcells. Subcells are otherwise called as orbitals. Okay. So here N1 means it is S1. Okay. N2 means S and P orbital, and N3 also S and P orbital, and coming to S4 it coming to SPD. And fifth period also SPD orbitals are coming up, and going to 6th and 7th we have SPDF suborbitals. Okay, so electrons are filling likewise. For group 1 only S, for group 2 and group 3 period 2 and period 3 it is S and P suborbitals, and 4 and 5 it is SP, D orbitals are there, and 6 and 7 we have 4 suborbitals for electron filling in the elements. Okay, so we see about period wise now. So in first period, the n equal to 1, it represents the K shell. There are two elements, one is hydrogen and another one is helium. Okay, so what is the electron filling in hydrogen means it is filled in 1s1 orbital, and for helium it is 1s2 orbital. Okay, so it is an completely filled orbital, so it is act as, or it have an property like noble gases. So that's why this 1s2 helium are positioned along the 18th group. Okay, and in n equal to 2, totally we have 8 that represents the L shell, and we have 8 elements. We have 8 elements starting with lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Okay, so these are the n equal to 2 period 2 elements. So here starting with this atomic number is 3 and beryllium atomic number is 4. Here 5, 6, 7, 8, 9, 10. Okay. Here how the electron fill in lithium means 1s2 and 2s1. Okay. Here hydrogen it is in 1s1, for lithium it is 2s. Okay. So here what is that means, the energy levels increases, that n equal to 1 to here n equal to 2, the energy level increases, and for beryllium it is 1s2 and 2s2. Okay, so first one it is filled with s1 electrons, and group 2 it is in s2 filling. Okay, so next so group n equal to 2 it is filled with L shells. So for a neon, this lithium is an first element, so it filled with 1s2 and 2s1 configuration, and for neon this atomic number is 10. So electron filled is 1s2, 2s2 up to 2p6. So here total 10 electron is there. Okay, so 10 electrons fill like this, 1s2, 2s2 and 2p6. Here this lithium and beryllium belongs to S or S block elements, and this another 6 elements are belongs to P block elements, due to according to filling of electron in the suborbitals. Okay, likewise N3 also have an 8 elements. N3 also have 8 elements. So it represents M shell, M main shell, and also subshells is SP or orbitals. Okay, here the starting element is sodium, which atomic number is 11. Okay, so here magnesium 12 and aluminium 13 up to argon. Okay, so 13, 14, 15, 16, 17 and it is an 18th element. Okay, here also sodium is 11 electron. Okay, so how its electron filled means 1s2, 2s2, 2p6 and 3s1. How it energy levels are arranged means in by Aufbau principle. Aufbau principle. Okay, these energy levels are defined by Aufbau principle, and according to the atomic number the electrons are filled like this. First electron will filled in first subshell S and electron are filled in another subshell P, and it goes to, because it is a third period, so its last electron filled in 3s series. Okay, like lithium is 3 and this last electron filled in 2s1 and 1s2 is a complete shell, and before that the hydrogen is filled in 1s1 position. Okay, here the s orbitals energy are increased along the period. Okay, and here N3 also we have an totally 8 elements. The S block elements are here sodium and magnesium, and P block elements are starts with aluminium and ends with argon, and argon's atomic number is 18. Okay, here the electron levels are 1s2, 2s2, 2p6, 3s2 and 3p6. So totally the electrons are comes under 18. Okay, so that argon is a last number. Here argon, before argon we see about neon, it is filled with 2s2 and 2p6 level. So this complete filling of S and P orbital, it have a noble gas property. Okay, so likewise helium also have complete S orbital. Okay, but it has an property like an noble gases like argon and neon. So it is placed in the group 18th in the periodic table. Okay, and we coming to the 4th and 5th group. N equal to 4 means 4th period. The main shell is KLMN. Okay, N shell, and subcells are S, P and D subcells here comes. Okay, D subcell. So here N equal to 4th period, we totally have 18 elements. Okay, likewise 2R belongs to S block and 6R belongs to P block, and another 10 elements belongs to D block. Okay, so in 4th period it is starting with potassium. Okay, and calcium, and D block elements start, first one is scandium. Okay, it is up to 30 zinc. Okay, and the 31st P block element gallium, and 38 krypton. Okay, these are the elements present in the fourth period. Okay, this potassium is an starting element and krypton is an ending element. Okay, so here potassium is atomic number 19. How the electrons filled means 1s2, 2s2 and 2p6, 3s2, 3p6 and 4s1. Okay, 4s1. Here the energy level increases. So period is 4 and the energy level also 4. Okay, and for calcium it is same one and 4s2 is ending. 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. Okay, so here it is then electronic configuration of calcium. Okay, and what about d block elements means after 4s orbital the electrons are going to 4p, but before 4p energy level 3d energy level is there according to alpha principle. Okay, so according to alpha principle in between 4s and 4p there is an one existing energy level that is called 3d. Okay, so here 21 for scandium means the electronic higher valence electronic configuration. How we can write means for scandium 4s2 3d1, and along with this period the 22 means here the electron second electron filled in the d orbital. So d orbitals have filled with high number of electron is 10. For s electron it only 2 electrons are filled. For p orbital the total maximum number of electron filling is 6. For d orbital the maximum number of electron filling is 10. For f orbital the maximum number of electron filling is 14. So here is it is the maximum electron level for orbitals. So from scandium to zinc this 3d electrons are increases one accordingly. Okay, and then the gallium comes here. Okay, so for gallium the electronic configuration is 4s2, 3d10 and 4p1. This is the configuration of gallium, and here the 4p orbital comes to the electronic configuration. Okay, that's why for gallium to krypton the elements are comes under p block elements. Okay, so last element the krypton, which atomic number is 38. So its electronic configuration is 4s2, 3d10 and 4p6. Okay, so here s orbital maximum electron level is 2 and d orbital's maximum electron is 10 and p orbital's maximum electron level is 6. So it have krypton have 3 completely filled orbitals. Okay, so that's why it is placed at a noble gas group. Okay, so and another period the n equal to 5. So here the main shell is KLMNO is an main shell, and here the subshells are SPD subshells. Okay, here also we have totally 18 elements. 18 elements starts with rubidium and ends with xenon. Here the rubidium the atomic number is 37 and here the electronic configuration written as here the period is 5. Okay, so what is the electronic configuration ends for rubidium is 5s1. So we have total it 2 and it is 10 here. For 4s and 4p the 3D series is there. So here the 3D 10 and 4p 6 and 5s1. This is the right electronic configuration for rubidium. Okay. So here the electronic configuration starts with 5s1. Okay, lost valence electron. Here strontium it is 5s2. Okay, here also the ytterbium to cadmium it is belongs to d block elements. So after 5s orbital the electrons are going to filled in 4d orbitals. So here the electronic configuration of ytterbium is 5s2 4d1. And what is the cadmium electronic configuration is 5s2 4d10. And that only for indium, the atomic number 49, the electrons are going to fill in the 5p orbital. So for indium it is a 5p1 electronic configuration in outermost shell. For xenon it is 5s2 4d10 and 5p6. So here the complete electronic configuration, because the sdp suborbitals reaches its maximum electron filling. That's why the last elements are acting as a noble gases. Okay. So here another two series groups or periods are there. That one is n equal to 6 and here the shell is P. And what is the subcells contribute in this period means the total 4 subcells are contributing for n equal to 6 and n equal to 7. So here the electronic configuration, outermost electronic configuration for cesium is 6s1 and outermost electronic configuration for francium is 7s1 and for outermost configuration of barium is 6s2 and radium is 7s2. Okay, here two series are there. Okay, one is lanthanide series, another one is actinide series. Okay, here for 6s and 6p, here we need to fill in the 5d orbital. Okay, and here 7s and 7p, in between we are filling in the 6d orbital. Okay, before 5d and before 6d, there F subcell is there. Okay, so for this series lanthanide to lutetium, the 4f orbital is actingly coming first, then the energy level of 5d going to next, and after 5d the electrons are going to fill in the 6p electrons. These arrangements are according to Aufbau principle. Okay, and here also 7s and 6d we have to fill in 5f before that. Okay, so these series are called as actinide series. Okay, here for lanthanide series totally 14 elements are there. Okay, and for actinide or actinoid series, that's also have a 14 elements. What is that means? The elements from lanthanide to lutetium, and the actinide series starting is actinide to lawrencium. Okay, so why it is belongs to 4f and 5f means in this 14 elements are have an same physical and chemical properties. So that's why this 14 elements are mentioned in the one box in the periodic table. Okay, 14 have same physical and same chemical properties. So that 14 elements are represents in a one box in the periodic table in the name of lanthanide, and in the 7th period these 14 elements have a same property. So that 14 elements also represents in the one box in the periodic table, and that is also called as actinide or actinoid series. Okay. So after that, for in 6th period, the thallium is an first element of p block elements. Here the thallium atomic number is 81 and its outermost configuration is 5d10 and 6p1, and for radon 5d10 and 6p1, and for radon that is 6s2 5d10 and 6p6. So complete configuration. Okay. And in the 7th period it is likewise 6. Okay. Here the shell is Q and subcell is 4 subcells are participating in 7. Okay. Elements filled in the periodic table along electronic configuration with period. Okay. So we have totally 7 periods in the periodic table. We see about the elements in period wise. Okay. Here 7th period the francium's electronic configuration is 7s1 and its actinide series the electronic configuration for actinide it is 5f1, for lawrencium it is 5f14, because f orbital's maximum electron filling is 14. So the last element have an complete filling of f orbital, then only it goes to 6d series. Okay. Next the 6d series ends with cobernicium, that atomic number is 112. Okay. So here what is the outermost electronic configuration is 6d10. Okay. And the p elements of 7th period starting at nihonium, that symbol is NH and atomic number is 113, and its outermost configuration is 6d10 and 7s1. For oganesson we already know that 7s2, 6d10 and 7p6. That is the outermost electronic configuration. Okay. Here oganesson also have a complete shell of electrons, so that's why it is placed under the noble gas group. Okay. So here the last groups are considered as a noble gas because of completely filling of orbitals. Okay. So today we see about the electronic configuration of elements in periodic table. The first shell, the electronic configuration along period is we detailedly see. Okay. In next class we see about electronic configuration along group. For along group we have classified the elements into 4 block elements, that is S block, P block, T block and F block. Okay. Thank you.